Let's start this webinar by my short introduction. We're really happy to present you today this interesting presentation of steam generating heat pumps. And if, like me, you love the subject, I'm certain that you will be satisfied with our webinar. And if you're not familiar with the steam generating heat pump subject, then I hope that you can be as enthusiastic about it as me at the end of the day. My introduction will be short. I will speak 2 slides about information about this webinar, and then I will present our Applied Science University, OST, and our Institute of Energy System, and then I will do the agenda. As I say, the webinar is recorded, and I will cut then the videos, and then they will be published on the YouTube channel of the project Suite DecarbCH. And this project I want to thanks for their help and financial help. And it's a national project, a Swiss project, Suite, which is Swiss Energy Research for the Energy Transition. And DecarbCH means decarbonization of cooling and heating in Switzerland, with the following motto: facilitate, speed up, and de-risk decarbonization of heating and cooling. And thanks for the help, we can organize webinars such as this one to help industry decarbonize. And you can follow on LinkedIn if you're interested. We are really thrilled to have more than 730 webinar registration. That's quite crazy, from exactly 50 countries, mostly from around here, Switzerland, Germany, Italia, and Denmark, but as well abroad, like in US, Australia, New Zealand, Korea, and some African country. And most of the people here are engineer and researcher, but we have as well some management, director, and sustainable people. Shortly, we ask people who register where they're coming from, and a quarter are from the work in the research and academia. So I'm certain you will appreciate this webinar. Consequent amount of people as a manufacturer of heat pumps. They know the subject. They will probably learn some other competitive or other company working on heat pumps. And I'm really thrilled to see as well around 20% of people following today are working as a planner and consultant, because I think that they are really key people to help and to speed up the decarbonization of the industrial sector. Most of you are familiar with the heat pump technology, or somewhat familiar. And so really happy, because that was exactly the public we are trying to reach for. If you are in the few percentage of people who doesn't really know heat pumps, maybe it will be a bit too quick, but I think most of the people here today will be happy with our content. In terms of really specific steam generating heat pumps, people are not work with them, but they are really interesting. Most of the people more they have, so I think it's really perfect. And what you're looking for into this webinar is learning about real case study. You will learn about it, so I'm really happy, and I'm really certain that you will appreciate today's presentation. Let's present to you where I'm working. So I'm part of the OST, which is Swiss Applied Science University, and it has 3 campuses. And the campus I'm working with a beautiful view is in Bux, which is really close to Liechtenstein, Germany, and Austria. And in our institute, we have 3 groups, and one of the group is the WPZ, Wärmepumpenzentrum, which is a heat pump test center, which can do certification of residential heat pump. We are working mostly on these 4 subjects, which are residential heat pumps, industrial heat pumps. The group in power electronics are working mostly, they're specified into mobility, inductive charger for really consequence high power, such as truck and cars. And we have some people as well working in energy supply. So Cordin and I are working in this institute since 10 years and working into the theme of high temperature heat pump and steam generating heat pump for industrial sectors. And what we're doing is mostly disseminates and teaches. We are doing some measurement and testing, as well as advising and consulting mostly Swiss companies. And below that, we try to advance the research as well in the domain. For example, as one in 2023 and 2024. The videos of the webinar are on the YouTube channel if you miss them. So feel free to have a look. And we've done as well really a lot of presentations, some online, some at the conference on the subject of high temperature heat pumps. In terms of teaching, we are doing since a few years a 4 days course, continuing education course on industrial heat pumps. It happens twice a year, once in German, once in English. The first 2 days are courses, and they are also available online, which can be interesting for people abroad. And after third day is a laboratory tour, and the last day it's an excursion. So really interesting course that we developed there in our institute, and for people living close to books, to the area where we are working, we have diverse CS, which is Certificate of Advanced Study courses. There are, I think, all or most of them in German, and the link is there. In terms of advising and consulting work that we are doing, we are just finished a Swiss-funded project which was called INTESGHP, which was integration of steam generating heat pumps, where I analyzed 3 Swiss companies, and you can see the results in the link when you download the presentation. And Cordin was part of the HTHP-CH, which was the pendant of Annex 58 on integration of high temperature heat pumps in Swiss industrial processes. They also work with 3 Swiss companies, Elsa, Cremont, and EIGVD, and CSD Engineer. And parallel to that, Cordin and I are doing a lot of direct consulting with Swiss companies. Many of the projects are under NDA. In terms of measuring and testing, Cordin, one of the first who published high temperature heat pump results up to 150 using this HFO and HFO. We develop as well butane steam generating heat pump in our lab using standard component. And once we produce the steam, we collaborate with EPFL. The EPFL develop a really small turbo compressor so we can increase the pressure of the steam. And that was a project as well funded by Swiss founding. So that's for measuring and advancing the research. We are part of a mixture of refrigerant to be able to adapt the glides of the heat pump to perfectly fit the application in the industry. So the idea is not to use standard mixture of refrigerant, but really to customize the best mixture to fit the application in a particular industry. We have really interesting results, and if you're interested into the subject, feel free to contact us or look into the link. Then we are part of various national and international projects like the EU project Push to Heat and Zimba, the Swiss Sweet Decarb project that I presented shortly, and of course another project funded by the Swiss National Fund is a Decinel project I'm part of, which is a decarbonization of industry via electrification. And I just want shortly to speak about what I'm looking at during this project. So here's a graph of a steam demand for a company for 3 months. Every block is a week. During the weekend, they don't produce. And you can see the steam demand vary greatly from 1 megawatt to they have a peak of just below 3.5 megawatt. And during the discussion, we did a bit of consulting for this company. And during the discussion, we discussed about how big the heat pump should be. And I think it's quite important. And it's not easy to find, especially with such a graph. So what I've done, I made the load duration curve, which is in the x-axis, you don't see it really well, but it's simply the percentage of the time that the demand is higher as what's shown in the epsilon axis. So we can see there really, maybe heat pump with 2 megawatts will produce 96% of the time, and the rest we can find another way. And I want to go a bit more into detail. So what I've done, I say, okay, let's use this load Okay, for most time I'm using a heat pump to produce the steam. For the really high power, I will use the heat pump and electro boiler. And because I know that the heat pump cannot do maximal heat capacity until 0, like I use 30% of the max capacity. And below that, instead of having a heat pump which will be tacking or using a storage, I decide in my assumption that I use electro boiler. And using these three solutions to produce the steam, I could calculate, assuming some cost of electricity and some efficiency, because I knew the COP for this particular case, I could calculate the cost of heating. And that's the cost of heating up depending on the size of the heat pump. And you can see that the heat pump optimally it's between 1 and 2 megawatts, particularly for this case, about 1.7 megawatt. And the size of the electrical boiler is calculated as well. So that's the cost of heating. So using electricity for the electric boiler and the heat pump. And when you see again the first graph I show you, you can see the line. And yeah, it's hard using just this kind of graph, the steam demand, to know exactly what will be the most cost-effective heat pump. And why the reduction, why the curve is like that? Because if the heat pump is too small, then we use the electro boiler much more, which is a higher operating cost. But if the heat pump is too big, the capital cost, the capex is as well higher. So this kind of work, that's why we're doing in our institute. That's what I wanted to present for this introduction. Now, in the name of our institute and Corinne and myself, so we welcome to this webinar, and we are sure that it will allow to disseminate the knowledge about steam generating heat pumps more broadly and help us and others to advise a company and anyone interested in the best possible way. That's all for me. I leave the floor to Corinne. The floor is yours.
Thank you very much, Fred, for this perfect introduction into the field. And we have Ru Wang from China, then Guido Sutter from Nestle, Abdel Malek Bari and Peter Kaden from Mayakawa, Davide Rizzi from Turboden, then Stefan Bertsch from our University Ost, Andre Bechem from Heaton, Tor Martin Wade from Olvondo, and José Luis